Marty began repairing optical equipment such as microscopes, levels, and transits with his dad in 1978. After graduating high school, he obtained a degree in electrical engineering from the University of Nevada, Reno in 1985. Over the years, he has focused on repair optical and electrical surveying equipment, factory trainings with Nikon, Topcon, Nokia, and Trimble, and has seen the evolution of electronics into the surveying world. Applications of our measuring tools is an exciting challenge that Marty welcomes for many, many years. Although when I looked up your thing on your LinkedIn, I was quite shocked at how many years. I mean, obviously, it's been with a couple of different companies that over the years that Marty's or that Monson probably purchased. Or I don't know the exact history, but I mean, I remember Marty's been around my whole career since I started surveying in Las Vegas in 1997. So um, it's been a while, and I was pulling up, and I'll find them later, and I'll throw them in a Dropbox. But Marty used to write an article, the technical sides is kind of what it was called, but for many years in the Traverse, and I'll go find those particular articles, and I'll throw those in a Dropbox link that go with this, just to kind of show the evolution of the years of how we've kind of transformed over the years, but and I guess still kind of stayed the same, right? I'm sure you'll talk about that a little bit, but how that goes into it. But I appreciate your time, Marty. This has always been one we when we chatted about a month ago. This was one of the ones that a topic that somebody was interested in kind of talking about and understanding the importance of it. So, and then we even talked about it with seeing how your side with the construction, training the construction trades, and the importance of understanding calibration of rods, just a simple calibration of rods, right? Which we deal with every day as a surveying firm. We have a little jig set up in the office that makes sure everybody plumbs up their rods at least once or twice a week. So it's important. So I will turn it over to you and stop talking.
Okay, so like Trent, like Trent says, this came about because somebody asked about, how important is it to calibrate your robotic rod or your GPS rod? Well, that opens a big can of worms, because when it comes down to it, it doesn't matter what you have. You could have a 50 or $60,000 robot, but it's only as accurate as your accessories.
Yeah.
So we're going to start off with a little bit of an overview of some optics. Um, just kind of, get an idea how the instrument works a little bit. And then, we'll finish up with instrument accuracies and uh, basically how to check your rod, because that's what the focus was initially. I had so I have some a slideshow that I use for some different things. So, like I said, your instrument's only as accurate as your accessories. Unfortunately, all these pieces and parts get thrown in with the shovels and the picks and the hammers and the rebar, in the back of the truck. The robot gets to ride up front, hopefully. But that's where the rod should be also. If we start into some basic optics, um, these robots, they're using compensators. So we go back and we just start off with like an optical level, a mechanical compensator. So what this is doing is it's compensating your line of sight so that it shoots level. Basically, that lower piece, that prism or mirror on the bottom, number five, it's like on a glider. It's hanging from four wires typically. Some of the really old stuff was like a ball bearing mount. But typically, it's a wire hung compensator. And uh, old school was when you're looking through that level, you tap the legs to make sure that thing's dancing. Because what can happen through use or riding in the truck is that the stops, the limits will stick. It'll create little dimples in the metal and create static and dust and it's a very very light assembly. So you give it a spin and it'll slide to the outside and it'll stick. So when you tap the legs, you can if it's dancing around, you know that it's good. you're shooting, 8 feet on the rod and you tap the legs and it drops down to 5 feet. Well, you know that thing's sticking. But once it drops down and it's dancing, you should be able to use it. Um, there's the same what that typically looks like. The other thing on a compensator like this, something that can go out of adjustment is you want to make sure that as you move the instrument out of level, um, it'll compensate back to the same point. So you can be looking at the rod and you move it out of level a little bit, and it should compensate and come back up to that same spot on the rod. Same thing in the other direction. Slowly bring it down, and it should go back to that same spot. With the total stations, we're going to see an oil compensator. Oh, one more thing on auto levels. Digital rods. The digital rods, the instrument doesn't transmit anything. It's just reading the ambient light off of this barcode, and it's impressed upon a CCD array. In the case of the Zeiss or the Dini Trimble ones, it's about 3/4 of an inch long, and there's about 1,500 pixels in there, and it'll read that image, and it knows through the processor, where that orientation is going to be on that rod, what the elevation is. Also, the farther away it is, the closer together these lines will get, so the instrument can tell the distance. So, with the evolution of the digital levels, you're able to bring in not only a rod height, but also a distance, which will help you, if you're doing like a least squares adjustment. These digital rods, they need to be in good condition. Um, Usually, if it's there's something's not, it can't read it right, or there's something else being introduced into the solution, like another line, it'll error out and it'll say it can't read the rod. We did have an instance where somebody was making marks on the side of an inbar rod. I think Trent was on that crew. They were out at the Vegas airport, and they had invar rods, and the invar tape. Some of the paint was coming off, so they couldn't use that section of the rod. So they put big lines on the side of the rod, so that when you're looking through it, you'd know that this isn't an area that you should use. But once in a while, somehow, it was picking that up, and it was blowing elevations by 3 or 4 feet. And round and round and round, I checked that level 4 or 5 times, and finally I said, "Let me see your rod." And they brought this rod in, and it's got all these black marks on the side of it. And I said, "You can't do that." um, another one, another instance that came out of the airport too was one of their levels would always come in because the compensator was sticking. And one day, um, there's Jim Turner. He says, "Well, I got to take my truck in to get it serviced. They do this every year because it only shows I'm getting 3 miles to the gallon." Well, he was constantly at the airport, and when you're out on the tarmac, you can't turn your vehicle off. So it was constantly running. And his auto level would sit in the truck, and that compensator was just constantly vibrating all day long. And it would make those marks, and eventually it would stick. Uh, Old school digital levels, not digital levels, sorry, old school auto levels, like a Zeiss Ni2 or a Wild Na2, they were put in the case either upside down or inverted, on their face. That's how they were mounted. And that's the best way to transport an automatic level. So the compensator is not constantly just moving. Typically, the Zeiss Dinis are on their side. If they're not, it's best to transport your level either on its face or upside down or on its side, so that compensator is not just continually banging away. And I think so. The total station compensator is an oil compensator, and with the advent of the of a CCD, we're able to transmit an image off of a prism. It hits the the meniscus of the oil and comes back and is read by the CCD. So when it transmits it, it'll send out like a mesh, a barcode mesh, and that image will come back and the CCD will read it and it can tell, what the orientation of the instrument is. These are oil compensators. It's best to keep your instrument upright, but if your robot's laying on its side, just let it acclimate for 15 or 20 minutes before you want to do something accurate. Let this compensator settle down. Angle systems, old school angle systems. Um, I don't know if there's anybody older than me and Jerry, but you used to have to index the telescope. So like if you're using a Topcon GTS 3B or the Sakia sets or something like that, it was incremental. So it would count these lines as they go through. I think the next slide, yeah. So light would go in between those lines. So the light would go on and off, and you'd get a sine wave, and the processor would chop the sine wave into squares and count it. But it had to have a starting point, so that's where you had to index it. And as you moved it through 90, it would see an extra pulse on that glass, and it would say, "Okay, start counting right there." The newer systems are what they call absolute, where any image on the encoder has a digital signature. So they'll shine light up off of a reflective surface, and then a CCD will read that. And I don't know, you can't really see that, but there's lines etched onto that piece of glass. And in the case of the incremental systems, they started out with an image that was about 4 or 5 meters in diameter, and it would optically shrink it down, etch it onto a piece of glass. And basically, there's like 1.6 million divisions around this encoder, and microscopic, but the CCD can pick it up. So the newer systems are all absolute encoders. You're going to see something like this. So there's no reason to index. It's always going to have a an absolute point that you could then go in and define like a zero set. It just gives a new index on the circle. Now the problem with all these encoders, even with the old glass theodolites, was that you can have eccentricity errors. So that piece of glass could be mounted to where when you rotate it, it has some eccentricity. And as you get from one side to the other, the images aren't going to be exactly 180 degrees apart. So for years and years, when these surveyors were setting up these open frame theodolites, they were having to go through some pretty rigorous adjustments for real accurate measurements. And Dr. Wild came up with the idea of reading both sides of the circle simultaneously optically. So if you look at those instruments that are on Jim's page there, they will read both sides of the circle. And if you're old school and you know what a mask looks like in the theodolite, you'll see a couple of lines in there and one complements the other. So one's inverted. And if there's eccentricity, as you rotate the circle, they will complement each other. So it'll negate any errors that you have in eccentricity of that circle not being centered on the axle. Probably trivia that people don't need.
No, no, it's important. It goes back to kind of like the fundamentals, right? Like understanding
Yeah.
how it works. It's no different than that. So,
Well, sure. I
just
mean,
so, yeah,
this is
exactly.
your robot. It's the same thing.
It's the same fundamentals it was based on. Yeah, exactly.
Yep. So you got your trunnion axis and then your horizontal axis.
Yep.
or some people call it a vertical axis because the bearing's actually vertical. But it's the same thing. It's identical. They just put an encoder on the thing so it reads it electronically. Then you get in there and you add on EDM and trackers and all kinds of different things.
So while you're on this particular page, you talk about those notches. So when you switch out a battery on a robot, you don't necessarily, you can basically just put the battery back in and set zero, or obviously you're going to check in, but I mean that's how that technology works, by being able to just do that because it's reading these engravings
Yeah,
on the
some
thing.
softwares will allow you to do that.
Yeah,
I don't know that Access will allow you to do that. I
right.
know FieldLink will,
Got it.
and I'm not familiar. I mean, most of my current product knowledge is Trimble.
Right. Yep, yep. And George did join us, FYI. So you got a couple guys in here.
Another dinosaur?
Yes. He takes offense to that.
Uh,
Sure,
distance
Mark.
measurement.
Pretty sure I'm older than you.
I'm pretty sure too.
That's a good thing
For me,
for me too. I'm still here.
okay, so distance measurement. Um, the old distance meters, uh, if you know the old stuff, the old top mount distance meters, they were a phase comparison. They would measure internally and externally, and then they'd have one transmitter at like 15 megahertz, and then they'd have dividers that would um, um, knock that down to something. I take that back. They would have dividers to make the frequencies longer. So in the old school, you hear about these things, the EDM rollover at 2,000 kilometers, at 2,000 meters. And what that was they'd send out a frequency of like 570 kilohertz and another one at 540 kilohertz. And they would go through a cycle and they would travel 2,000 meters. And then at 2,000 meters, they would converge again. So if you measured 2,001 meters, it would tell you it was a meter away. So on the 15 megahertz signal, they measure internally, externally, and you can tell what the where that wave was when it came back. So, if you're a quarter of the way through the wave, you go, okay, that's 0.25 meters, and that would take 6, 7, 8 seconds if you got a good signal. The newer EDMs are time of flight, so the electronics are fast enough to just time how long it takes for it to go out and come back. Which then led to the evolution of the scanners because you can transmit and receive simultaneously. Some of the conventional robots that we use, like the S series, they have 10 or 20 meters of fiber optics inside there because it's hard to measure zero. So if you were right up against it, it's like it sends out a pulse, and a half a nanosecond later, it gets it back. Well, if the distance is actually 20 meters, then you got 1 nanosecond before it comes back. So it's easier to measure. It's hard to measure zero. So there'll be fiber optics in there, and the fiber optics are they're pretty durable. I mean, these things, obviously I see them, they hit the ground, and the protective cans that have the fiber optics on them will pop off, and we're able to put them back together, and the fiber optics aren't really harmed. Distance measurement, atmospheric conditions. Um, these frequencies are just above the light that we can see. So basically, it can see what you can see. If you're out there in the heat waves and that thing's dancing up and down, that's what the EDM's seeing. That's what your tracker's seeing. Um, if you're in Vegas and it's 130 degrees and it's a 40-mile-an-hour wind, the heat shimmer is actually right to left. it's pretty daunting. Um,
Since you're on this particular one, the atmospheric conditions, can you talk about like the importance, or maybe it gets into it farther, but the importance of barometric pressure and temperature, and so that it adds that even in today's technology equipment?
yeah. So it's going to have an effect on longer distances. If you're 5 inches off on your pressure, it's going to be an error of 0.003 of a foot for every 1,000 feet you measure. So not super, super critical.
Got it.
But when you start getting out, 2,000 or 3,000 feet, in the old days, we had guys measuring, 20,000 feet
Right, right. And that's
hilltop, hilltop.
yeah, I was gonna say with the robotics now, I mean, we're not getting that far with, obviously Bluetooth technology. So I'm just kind of curious on how important and what that air would be. Because obviously we're not getting more than a quarter mile, sometimes 1,800 feet at max now with Bluetooth when it comes to that stuff. So I was just curious.
Yeah, I have an old school PPM article I can scan and send over to you. You can put up on the page.
Oh, okay, cool. That'd be awesome.
And then I've got some other stuff for you too.
Sweet.
When you talk about those distances, also, the ideal range for a robot is 600 or 700 feet.
Okay.
Because right in that area is where the accuracy of the EDM complements the accuracy of the angle system, provided that you're, a 2 or 3 second instrument. Beyond that, the EDM is more accurate than the angle system,
Got it.
and vice versa.
Got it. That is good information.
Reflectivity of the target. This mostly comes into play for um, reflectorless measurements, direct reflex, measuring without a prism. Um, if anybody's done any scanning and you see highly reflective or black surfaces, you don't get a return.
Right.
It's black because light doesn't reflect off of it. That's why you can't, that's why you see black. If it's white, it's bright, the light's reflecting.
Yep. I know early on, George has his hand up. One second, but I know early on with some of the Cyrexes and things like that, somebody scanned a car and they cover it with flour so that they could get it to scan, right? Like get that bounce back. So go for
Yep,
it, George.
exactly.
Yep. Nope, you're muted, George. There you
This
go.
is kind of off on a tangent, but Ray Martin and I laid out the race course for Richard Noble back in 1983 for his land speed record.
Hmm.
And we used an EDM. We took 1 mile measurements instead of point every 1 mile. When the timing association came back and measured the mile that was going to be officially timed in the middle, they used a 100-foot chain. They did chaining bucks and and took temperature corrections and everything else, which we did too as well, barometer and temperature. We paid close attention to that. I'm wondering what your thoughts are on the accuracy of their measurements compared to one shot with an EDM. And we took multiple shots after we set the point, obviously, to make sure we were right, but with our equipment. But I'm wondering what you think the difference would be between 53 pulls with a 100-foot chain and one measurement with an EDM over a mile.
Yeah. That's a loaded question. I
Well, yeah, it is.
love it.
I will tell you,
Well,
I will give you an answer that they gave me.
Okay.
They were within a tenth of my measurements,
Okay.
tenth of a foot.
it's not bad.
No, it's not. Well, neither one is bad, but I still got to say there's more error in 53 measurements than there is in one if you pay attention to what you're doing.
Yeah.
Well, there used to be a day too when, the surveyors were going out to the sewer plant here in Reno, I know, and calibrating their tapes, calibrating their chains
Hmm.
because they had a good underground controlled environment.
Oh,
to be able to make that measurement. Um, when was the chain checked? Did they check the spring pull, the tension
Oh
pull?
yeah, they use chaining bucks and everything.
yeah.
Yeah.
And, but I will tell you, it was hotter than hell out there.
Yeah, well, if it's really hot, you don't have to pull more than 2 or 3 pounds, probably.
That's probably true.
That is a whole nother session right there.
Yeah,
Yeah.
but I just always wondered about that. I mean, is there a reasonable way to even make a comparison? Probably not. And in the scheme of things, a tenth of a foot in a mile is what, 1 and 52/8.
Right.
Yeah, but did
Who cares?
they go out and come back? Did they measure it
Uh,
twice?
they measured one way.
Oh, well,
It was too hot to go back, and
So,
I think they were out of water.
so you're saying the land speed record's within a tenth?
Well, yeah. Well, the accuracy of the land speed record is 1 in 53,000, roughly.
There you go. All right.
yeah, exactly. Yeah. I was just gonna say that.
Yeah.
It's been reset since, so it's a mute point. But
There you go.
but just just thought I'd toss that out there.
Yeah. Well, and not just again, not to sidebar, but we've had to certify Olympic swimming pools too, right? And so understanding those kind of things, the air measurements and those kind of things, PPMs, when you're doing that to
Mhm.
that same point, George. So
Right.
yeah. Sorry, Marty.
Sure. So when you measure a pool, is it to the inside wall or is it to the lip?
It was to the timing pads, actually.
Oh, okay.
Yep.
True. True. They got to hit those pads.
Yep. It was to the timing pads. So
So here again, your accuracies are dependent on your accessories. If your tribrocks are bad, they're not calibrated right. If your stuff's bent, if your glass is inaccurate, if you bought it from China for $30, if it's got chips in it, um, and then obviously your setup. Same thing with the instrument side. Is your optical plummet calibrated? Is your instrument calibrated? Prisms and coatings, their conditions. Coatings. Um, it's been found that um, the SX10 and SX12 instruments don't do well with copper coated prisms. Coated prisms are great because it used to be, they didn't have any coating on the back. So if you got moisture or anything on the backside of that glass, it was gonna back on your reflectivity. The can would get broken, it'd get full of dust and stuff like that. So it's not going to be that reflective. It's not going to mess up your accuracies. Um, the coatings, you can look at them. Some of the old HP glass was coated, but you can see when the coating's coming off. You can see on the backside of that surface that coating's coming off, and um, being another reflective foil, let's say, on the backside of a retro prism, could affect the accuracies of that. And then obviously know your target. When we're talking about distance measurement, going in and checking something like these baselines. Um, I have people call in and they say, "Oh, I checked it on the baseline." Well, when did they check it? Well, NGS certified my baseline in 1978. And are you in a floodplain? Are you in an earthquake zone? Is it also a runway? Did somebody park a crane on top of one of your control points, like happened in Las Vegas? We had a pretty good baseline at UNLV, and one of the points was off, and it was before they built one of the buildings. And I went out there one day, and you could see this giant tire mark over the top of this. Now, granted, it was a 5-foot column set down into the ground, but somebody parked a 45,000-ton crane on it, and it was off. So
some of those points are still in, FYI.
again,
Some of those points are still in.
I
So
hope you're not using them.
no, no, no. We used them for level loops for class.
The simplest thing and a great exercise for your people is to um, set 2 points with a middle setup, and then move the instrument over to one end and shoot the overall. Do the two distances match the overall? Then you know that they're doing accurate stuff. Because then is the instrument off? Are your tribrocs off? Is your OP off? Where is that error? And then redundancy. Add in another piece of equipment. If something's not right, put in another piece of equipment. Put it up a different piece of glass. Shoot all your glass. And soon we'll talk about rods. Where are we at? Oh, types of beat. So we talked about this time of flight. Reflectorless footprint. So, um, well, this is just kind of a block diagram of time of flight EDM with some fiber optics wound up in the transmit and receive side. Um, so when we take this instrument and we calibrate it, and we've got, it'll turn horizontal and vertical angles, compensator's good. Then we go and we put a distance meter on the same axis. So transmit and receive. So we'll have to go in and we have to adjust the fiber optics where they transmit and receive so that they are centered into the piece of glass for transmitting and receiving. If these fiber optics are changed or moved or anything like that, it's going to change your EDM offset internally. It's a calibration that we do in the shop. Then I don't know what my next slide is. Then they go and so this would be like a scanner. So basically, there's a mirror that spins in the middle of your scanner that um, transmits and receives that light coming and going. So the thing with scanners is, know your target, just like with the black. And I hate it when, they spec, oh, 1,000,000 points a second. What does that mean? Are you collecting 1,000,000 points or is it spraying out 1,000,000 points? You could spray 1,000,000 points at a black car and you might get back 5 or 6% of it.
All right.
So reflectivity, and I don't know how they do it, but like the SX10 and SX12, they're only putting out 26,000 points a second, but they're getting like 85% of it back. I don't know if it's the frequency or what. It's kind of strange. But when you look at these specs on these scanners, 1,000,000 points a second, what are you getting back? Um, so here again on this telescope, we got the same scope. We got horizontal, vertical. We got an EDM in there. Now we're going to put a tracker on there. So in that same optical axis, you're transmitting and receiving for a tracker receiver. Now the Trimble tracker receiver is a quadrant receiver. So basically that's 4 photodiodes and the electronics will just adjust the return beam from the prism so that the voltages on 4 photodiodes are equal. So as that prism moves, this thing's going to follow it to get that thing to go. Some of the Topcon and Leica systems is actually a CCD array. So it has a CCD camera and it will go and it will identify an XY pixel through calibration from phase 1 to phase 2. And it will figure out what that is. Now, when you go through and you do a tracker calibration with a Trimble, it might be like half a hundredth off the prism. You go through the calibration, it's still a half a hundredth off. In order to get that closer, that's a physical adjustment we have to do in the shop. When you do it with a Topcon or a Leica, it's going to go back to the center of the prism. So when they came out with this thing, I asked the Trimble techs, I said, why'd you do that? And they said, well, it's faster and more accurate. And yeah, it is. I mean, we see, um, our shop in Reno, we probably do 4 or 5 robot services a day. And, we're checking our rentals every time they're coming and going. And these things, they're solid. If it goes out and it's half a hundredth off, when it comes back, it's a half a hundredth off. It's not changing, it's not moving. Now, through the calibration on the Trimble system, it'll figure out, okay, well, it's 5 seconds horizontal, 5 seconds vertical to the right, and it will figure that out. On the Trimble system, to check and see that it is doing that accurately, you can track the prism and you look at your angles, turn the tracker off, it should go to the center of the glass and the angles don't change. Now, on some of the instruments don't even have an eyepiece, you'll never even know. SX10, SX12, the RTS 873, 871 series, they don't even have an eyepiece. Um, Same thing with scanners. If you're using scanners for any kind of collection or layout, that's just done through its calibration. The calibration on the Trimble X7 and X9 series, it's an internal calibration. Um, they kind of did something ingenious with this thing where, whoops, they built an autocollimator into the bottom of the instrument. So basically, like when we go through our calibrations, there's a laser down in the base that transmits through a series of prisms underneath so it gives it, like about a 10 or 12-inch length up through the axis of the instrument. And then there'll be a mirror in the telescope that reflects back and says, okay, this is my calibration point. Then the EDM transmitter will shoot down through that same axis and then turn itself 180 degrees and check that axis, and it'll do a self calibration. So this instrument self calibrates every time you turn it on. So the only time it ever needs to come in the shop is if something fails. So pretty ingenious what they did there. And I gave them a little education on how it worked when I was at the factory. Well, not the factory, but in Ohio. Beam divergence. So, oh, all right. So Trent, do I have to stop sharing? Oh
No, if
wait,
you, yeah, there you go. And now minimize that, and then you can go to your other picture. You had it as a JPEG or something. You had it open.
it was a PDF. Okay,
Oh, there
so
you go. Yep.
your beam divergence. This is great for a tracker because you're transmitting with your tracker, and the farther out you get, the easier it is for this thing to find you because you get out 500 feet and that tracker transmitter is probably, I don't know, 100 feet wide. So if that prism's anywhere in there, it's just going to grab it. Um, Beam divergence with a reflectorless EDM, what happens here is that when you go to measure an object, you need to be aware that um, your footprint is not a dot. Like if you're looking at it through your crosshairs, you're like, oh, I'm right on the corner of that building. That's not exactly where it's measuring. So you can see here how that can affect that distance, and things just might not work out right. Um, a lot of softwares will allow you to create a plane, so you can shoot, two good flat surfaces, and then project that point, doing an offset. So a lot of softwares will allow you to do that. So just be aware that your footprint, if you're trying to do some real accurate stuff.
Yeah, that's it. Those are great points. There you go.
These the lenses, they have a coating on them, and it obviously allows the light of the transmitting distance meter and tracker transmitter to enter the telescope. It keeps out harmful rays from the sun, um, and ambient light that can affect the performance of the unit. We had some of these underground, and they're constantly wiping the lens. Underground, 150, 200 feet in low light conditions, great. You take that thing out in the sunlight, you can't hardly get it to track 100 feet because there's just so much. So when you're cleaning these lenses, you want to be really careful. You can see this one's all, nice and shiny. So you want to be careful that you don't scrape the coatings off the surface because it'll really affect the tracker. Where are we at?
So
Oh,
what would you suggest cleaning with then, just so we don't scratch that surface in the
first, yeah, blow the dust off first, some dust air or something like that.
Okay.
And the old school instruments came with a little camel hair brush in them.
Right.
They don't do that anymore. It comes with a microfiber wipe, but you still want to get the dust and the gritty stuff off of there. Um, and then just a tissue with a little Windex or something.
Got it. Perfect.
A little note on data collectors. Horror stories, horror stories.
I've got a few myself.
We had some guy that was going to sue us because when we serviced his TSC7, it wiped out files that he had on there for 2 years.
Oh no.
And it was very critical because it was a court case.
Oh geez.
So it came down to the point. So, well, if we get the attorneys involved and there's an arbitrator, they're going to say, well, if it was so important, when's the last time you backed it up? And you're going to
Hmm.
say never.
Hmm.
And they're going to say, get out of my room.
Yep.
So he dropped it after that. What are you going to do? But back it up, back it up, back it up. And then also, not so much on the newer stuff, but like the older ones, even TSC3, if you have a file structure, you got job one, and then you got control points for week 58, sorry, week 51 and or 56. And then you got today's work, and then today's work before noon, today's work before 9. You got this file structure down there, they'll get slow. They will get slow because that's only like a 500 megahertz processor or something horrible.
Yep.
Um, Here again, clean it gently. Touch screens. um, a lot of the touch screens, there's a between the touch screen and the edge of the housing, there can be a little gap, and you get rocks, pine needles, pencil lead. From your mechanical pencil, it falls out and it's down in there. Sometimes it thinks it's being touched. Um, those screens have seals around them, and you can pretty confidently go in with like the edge of a business card and run it around the edge, and you're not going to mess up that seal.
Yeah.
And then,
One point on that backup is backup before you even leave the job site. So that was one we had. One got left on the bed of the truck and then drove down the freeway and didn't back up before they left the job site.
yeah,
And then that ended up
there's,
as a smashed pancake. And so there's
oh yeah,
there's a day or two worth of work, gone. So we make it a habit of trying to back up before you even leave the job site. So
yeah, you can set up your stuff, or like Trimble has Trimble Connect. You can
yep.
set up those things. Um, the previous um, vehicle, the Trimble Connect, some of the companies had their collectors set up so that when they pulled into the parking lot and they hooked up to the office Wi-Fi, they automatically downloaded. So before the guys even got in the building,
Yeah.
the crew boss already had their files. Screen protectors. Screen protectors are great. Um, most of the newer stuff on these Gorilla type screens is they're glass. Now, even with the old plastic type screen protectors or the glass ones, replace it once in a while. You know, at least once a year. This thing sits out in the sun, and that it'll bake that thing right on there. Um, I don't know if you've taken some of these screen protectors off, you try to get them off, and the glass just shatters. It's really, really hard. Like your cell phone screen protectors, sometimes you take those off and it doesn't want to come off and it just comes off in shards. And you got to be really careful because that glass will get in your shirt, your clothes, your beard.
Yeah.
Um, yeah, and then you take it home.
One question in there from Adrian is how often should you clean your lenses? I assume that goes back to the total station and the robot question.
Depends on your conditions and things like that. I mean, if you got moisture on there, you definitely want to clean the moisture off while you're operating it. And then if you're using the eyepiece, it's going to get muck on it. You can gently clean it with a swab, a Q-tip or something like that. And then
Adrian's Central Valley, so
okay.
Fresno, yeah, so farmlands, dust, dirt, those kind of things.
Yeah, blow the dust off of it and then just give it a wipe with a micro wipe. That's good.
Daily, weekly.
Oh, probably weekly.
Mhm.
You can do that.
Perfect.
Radios, we'll just touch on this briefly. Um, the radios are designed for specific antennas. This is not a specific antenna designed for this WIT 2.4 gig radio. Um, Now, a lot of these guys, they swear, oh, I get better range. Yeah, maybe. I I have never seen it. I've never tested it myself, but we see these come in, especially from some people in Las Vegas.
Not my firm.
No. Uh,
All I can think about is, a second ago you said it's kind of the robots are good for 6 to 700 feet, and this antenna, they're like, I'm going to push this thing to 2,100 feet.
um, with good antennas and good radios on these radios, which are also I know are used in the Leica systems, line of sight, 2,000 to 2,200 feet.
Yeah, yeah.
Yeah, that's not uncommon.
There you go. Dan's got a question in there. Go for it, Dan. Maybe. Mm, We don't hear you. Mm, Nothing, nothing, nothing.
Well, the other things on this screen were cables and antennas and settings. Was part of this slide was for like GPS base stations. I will say something, if you guys are running GPS base stations and 25-watt radios, either power that thing down by pulling the connector off of the battery or the power button. Don't unplug the power connector directly from the radio because if it's transmitting, and it's drawing like 8 amps, it'll smoke that connector.
Okay, that's a good point.
I know, like on the Pac Crest radios, the ADLs and TDLs, we replace a lot of those connectors because they're smoked.
Got it. Try it now, Dan.
Can you hear me?
Yep, you're good now.
Still nothing?
No, you're
Okay,
good.
there we go.
You're good. You're
I tested it before I got on today.
good.
So I have a Trumbull S6, and I had my antenna kind of break apart. The coating around the whip kind of deteriorated, and I had one that looked similar in size. How do you know if you have the right antenna for your equipment?
Mm,
So
Good question.
this is the newer one. There was another one that was a little bit longer, and it still comes with some of the EM120 radios um, that go on the back of the TSC7, TSC5. Um, and if you cut the end of that off, there's nothing up there. I don't know why they make them longer.
Okay, because when the one that broke came apart, like you said, there's a really short wire inside there. I'm not going to take apart the one that's not broke to see if it's the same length. So is there a number on there you got to look at, or
No, um, the only
mine is
thing, the
not,
only
mine's not as long as the one in this picture, so I should be good, right?
yeah, the only thing that they did on the newest ones was they put the Trimble logo on there, but
Okay.
but and then these won't work for the Leica. It's got a different connector.
Yeah. Okay. It fits on there. I mean, it works. I just was curious about because doesn't the antenna have to do with the radio wavelength or something like?
Yeah, it has to do with the power and the tuning.
Okay.
Yeah, it's tuned just for optimal power and reception.
That's
All
right.
right. Thanks.
All right.
Oh.
How to clean your equipment.
Uh,
So this is a good testament to how durable these things are.
oh yeah.
This gun's been underground for about 18
I was
years.
gonna say that looks like a underground mine.
Yeah, it came out of Carlin.
Yep.
Um, and they every couple of years they bring it in, they get it serviced. But what's the best way to clean it? Not
Oh,
like this.
I love that image. Oh, that's great.
So we use like you can use like 409, a magic eraser, definitely not on the lenses or the display. The minimal amount of moisture and toothbrush. You can clean them up. That gun that we did before is this same gun.
Oh my goodness.
So the guys in the shop, it probably took them an hour and a half to clean it. But you take the handle off, the tri-broc off, and just kind of get after it.
Yep.
Calibrations. When do I need to
I
calibrate?
was just gonna say that's where the collection of little brushes that used to come with the instruments
Yeah.
come in really
Yeah.
handy. There's soft ones and there's stiffer ones. They come in really handy for that.
Yep. It's if you go in your wife's uh area in the bathroom, you find the same thing.
Just
But
start just start borrowing the makeup brushes.
yeah.
Yeah, yeah. You do that once and that'll be it.
Don't do that.
Say,
Paint brushes.
why is your robotic got a blush on it?
Paint brushes too. You can just buy the 49-cent paintbrush or
Yeah,
something
yeah.
like that. Just something to just kind of get that dust off there.
Good.
So when do I need to calibrate? Obviously, if things aren't right, the serving instruments are repeating instruments. So, whenever you're doing control or tight work, you're doing phase one, phase two, right? So you take your observation and you invert it, and you go to the other phase. Well, I'm talking about phase one, phase two. Well, I'll do that later. Um, so when do I need to calibrate? So if it's got a bust in it, if you're doing rounds, you're going to get a round report. And it's going to say, oh yeah, you're blowing it by 10 seconds. You can do field calibrations. Um, the Trimble suggests that you do a field calibration if you have a change in temperature by 40 degrees. Okay. Now, granted, these are just to maintain the specified accuracy. Okay. Now we see temperature swings of 40 degrees every day, basically. You know, um, unless you're in Cabo or something, and then it's like 8 degrees. But in order to maintain the specified accuracy, that's what they say to do. Now, a lot of what we're doing is, if we're doing layout, just in buildings and things like that, it's flat, basically flat. So, some of these inaccuracies aren't going to bother you too much. If it's 5 seconds off to the left, it's 5 seconds off to the left everywhere you point it. If you invert it and you go, well, you're 5 seconds off to the right. So calibrations, um, ideally, what you do, first thing you do is your compensator. So it's got to be level, right? So once it's level, you can do horizontal and vertical calibrations. Now, when you start off, you can level it up, and you do a compensator calibration. So in your instruments software, either on board or on the collector, it'll have a compensator calibration. So everything's going to be based off of the base, right? Then you can do horizontal and vertical calibrations. So it's going to calibrate any split that you have in your horizontal and any error that you have in your index on your encoder. Okay. Then if you have a good target, like at least 100 meters away, and you can tilt that thing, to 30 degrees or so above the horizon, then you can do your phase one, phase two for your trunnion axis. Now, the trunnion axis is how perpendicular the telescope axle is to the spindle or the vertical axis. So if these two, are off a little bit, you have to bring that into calibration. Now, your robots have a dual axis compensator. So when that instrument is out of level on the y-axis, or with that trunnion, it'll take into consideration your horizontal angle. So if you turn a steep angle and you mislevel your instrument a little bit, it's going to change your horizontal angle because it sees that the telescope is now not pointing at that horizontal point. It changed. The Trimble ones, I think they call it sure sight or something like that. It'll correct for it automatically. Same thing with if it's shooting level, like an auto level. You can move the level screw and it'll correct for it and bring it back to horizontal. So then the other thing after that would be your tracker. Now your tracker is going to be based on how the compensator is calibrated, how your horizontal and verticals are calibrated, and then it will calibrate to that. If your horizontal and vertical calibrations are wrong and you go to calibrate your tracker, it's going to give you bad information, or it's going to store incorrect values. After that, the distance meter, shoot known points, shoot a straight line, shoot a point to the right, point to the left from the middle, and then shoot it overall and see if you can match it. Simple. Super simple. Other signs, if it's got a big dent in the side of it, you might want to actually take it to a shop. If it hits the ground and gets damaged and it doesn't want to turn, don't force it. If there's parts loose inside, don't turn it on. We had a surveyor I think it was a Topcon, and he said sometimes it wouldn't power up, but if you shake it and you get that screw to move somewhere else, it'll turn on. Well, dancing a screw across circuit boards that cost, $2,000 or $3,000 is not a good idea. We had customers that drop it and They said, well, when I turn it, it's making a screeching sound. So I did it like 50 or 60 times and it still does it. Well, what he did was all the increments on that piece of glass, he rubbed them off. So
Oh boy. Ouch.
yeah, had to buy new glass.
In the chat, he wants to know if you can explain trunnion.
So let me see if I got some.
You gotta look through
You know what?
his museum
Hang on.
pieces in the
I
office.
got a really cool whistler. Hang on one second.
Perfect. Jerry's gonna get up and grab something from the top shelf.
I actually have an old transit scope, but the axe is taken off the standard, but I don't know where I
Oh,
put it.
okay.
I cleaned my office. Now I don't know where the hell anything is.
If you wouldn't have cleaned it, you knew exactly where it was.
Yeah.
Oh, that's awesome. There you go.
And so basically, the instrument has bearings that the telescope sits on. And these bearings should be calibrated to be perpendicular to the turning axis. If this thing's out of adjustment, it's going to be off. And then when you turn it, it's going to be down here low and then it's going to go high.
Gotcha.
Does that make any sense? Does that help?
I think so. Does that make sense, Dan? You good? Yeah, I was gonna say it does to me, but that's awesome. Jerry, did you want to add to that? He's got kind of this. Jerry's got the same piece up there.
Yeah, basically this is a telescope off a transit. You can kind of see it's got the axis that comes across here, and that's the one that sits in the saddles of the standards. Yeah.
Got it. Nice. Sweet. I love it. This is awesome, Marty. Thank you so much.
Okay.
I know you got more, but this is good. That's what
What are the
that's what 46 years of experience does for you.
what are the specifications of my instrument? So the published specifications are based on this old German DIN spec or the new ISO spec, and basically, initially, what they'd gotten out of what the Germans wrote was that the instrument could turn back to the same point. And what they interpreted into in the new ISO standard is that it's a difference between phase one, phase two. Okay. Now I think what surveyors like to think or like to see is they're like, oh, it's a 2 second instrument. So I'm going to have a 2 second accuracy from this point to this point. And that's not what that specification means. It's just the ability of the instrument to come back to the same point when it's in proper calibration.
Nice.
So something to keep in mind. Something
Absolutely.
to keep in mind. So I did find something in an article, and I think it's in this one that I'm going to share with you, where through redundancy and statistics, basically you're going to see the square root of 2 times your angle for your accuracy measuring between 2 points, which basically equates to 40%.
Mm.
So if it's a 5 second instrument, you have 7 second accuracy.
Wow.
If it's a 1 second instrument, you can call it a second and a half,
Yeah.
or 1.4. All right. So now we're going to talk about rods. Now, I know Trent, what do you have in your office for the calibration? The Seiko one with the knobs up on top?
Yes.
Okay.
Correct.
that's what we use in our shop.
Yep.
There's a what they call a true plumb, and I don't really like those that much because you're relying on the gravity to plumb that rod. If the guys leave the data collector bracket on it or something, it ain't gonna be plumb,
Mhm.
and sometimes, you know, it's not the sharpest guy in the toolbox that's calibrating the rods. It's the same guy that runs the shovel. So um, what I've found in the field is, we've got a lot of guys out there laying out a lot of points, and their rods aren't that accurate. I'm even coming across surveyors that, I'm retracing some of their stuff they laid out and it's wrong.
Yeah.
So about 40 years ago, my dad came up with an idea, and I had him redo it, and we just made them in MDF because it doesn't have to be like nylon or aluminum or anything like that. George, you probably remember these. And basically, it gives you the ability to. Oh, I hit my mouse. Somehow, is my camera? Well, my camera's still on. I guess
No,
that's all.
yeah, you're good. Yeah.
So you can take this. You can take this and mount it on a tripod, and then you can just loosen up your draw screw and move this thing around. Get your bubble centered up, and then turn the rod 180 degrees and see if it's good or calibrate it if you need to. Now, it's what you see is twice your error. So I don't know if you can see that this is not plumb. So if it looked like my bubble was good here, when I turn it 180, it's going to be good here. So what you see is twice the error. Okay. So when you go to adjust your bubble, you just want to adjust half of what you see. And then you always want to try to make your final adjustments tightening. Typically, these bubbles have got 3 Allen screws underneath, 2.5 millimeter Allen wrench, and you can bring that thing into adjustment. Very simple in the field. Anybody wants one of these, let me know. And we'll send you one or two. It's so simple, it's ridiculous.
Nice. Yeah. That
Like I said,
makes
we
it
see
easy for the
so
field. Yep.
yeah,
How tight?
we see so many people that are out there and their rods are off.
Yep. That's the biggest.
How
That's
tight
the
do you
biggest
tight
source of
those
error.
Allen wrenches? Oops.
Sorry, Dan. Go for it, Dan.
How tight do you tight those Allen wrench screws on the bottom? Crank her down or keep her loose or what?
You can crank them down pretty good. You'll get the hang of it because you know you'll give it a push and nothing happens. Well, you probably shouldn't push it again. So you can loosen the other side and then tighten it back up. 'Cause you can strip them out, but
Yeah.
like how many foot pounds? I
Yeah.
don't know. It's just a
Yeah.
feeling. It's like it's about the size of like a 440 screw.
Okay. I've
And
always kind of gotten them kind of tight in the past, and always
yeah,
thought, well, do I keep them a little tighter than this so they don't keep loosening up? But
yeah.
I see what
No,
you're
no, no.
saying.
Yeah, tight's better. And then what we do on all the new stuff that we calibrate, we put a little bit of fingernail polish on there.
What does that do?
It just keeps them tight, keeps them from moving.
Oh, okay.
But we can also tell if somebody's been horsing on
Gotcha. Yep.
them. Now the older bubbles in the rods, they actually had a piece of rubber underneath of them. So you were just tightening that bubble down against that rubber. All the newer stuff has a pivot point. So there's a nipple on the bottom of that bubble. So it's just rocking around that nipple.
Gotcha.
And then you can get more accurate bubbles too. Typically the rod bubbles are a 40 minute. If you buy a replacement from Seco, they're red. The housing is red and they're 8 minute vials.
Hmm. Jacob, you had your hand up there.
Yes. My question for you is when calibrating your rod, one of the companies I worked for before, they would use their total station. They would shoot it and then they would turn it and then they would shoot it again. Um, and I was thinking you may run into more error doing it that way because before that company, I was taught to do it the way you just demonstrated. I would like a better insight on the two in comparison.
This is going to be a lot more accurate. Um, the total station is a great check. So if you got your glass up there and you look at your collector, you see where it's at, turn that thing 180 degrees and see how much it changes. That's a good check, but it's going to be a lot more accurate to just turn it on itself.
Appreciate that.
Yeah.
And then my message I put into the chat, I was asking if anyone still uses plumb bobs and peanuts with their total station instead of rods.
I would say more so for us, those we're using that stuff for anchor bolt certifications, those kind of things. That's where we're getting into the peanuts and plumb bobs and peanuts for us.
A
Very
plumb
cool.
bob is also a good way to check your optical plummet.
Yeah, yeah.
Well, you're on the instruments, most everything that's out there, um, the optical plummet's in the alidade, so you can turn the instrument on itself. So set it up over the point, turn it 180 degrees, see where it's at. If it's off, take out half the error.
Yeah, but if you're using a tribrac that you're mounting a prism in and optical plummet's fixed in the base, it doesn't rotate it. Way to check it's with a plumb bob.
Yeah.
But don't for the life of you hang a paper clip in those little holes in the instrument stem underneath. Those are never centered.
Yeah. They make adjusting pucks for Tribrox. It's a really good investment. They have a bubble on them, which isn't really worth anything. I would use the compensator on your robot to adjust your bubble. But the adjusting puck, you can put a Tribrock on a tripod, put that puck in there, put your Tribrock on that puck upside down, and then you can shoot a target on the ceiling and then turn it 180 and adjust your optics in your Tribrock. It doesn't have to be level, just like your instrument. It doesn't have to be level. All you're doing is seeing that those optics are perpendicular, coming out of that thing, perpendicular to those three buttons that the instrument sits on, those three pads. So it doesn't have to be level. You just want to see that those optics are rotating around this axis.
Nice.
If you're checking it on the instrument, it doesn't have to be level. But you just want to see that, I'm on that point, you turn 180 degrees, and I'm on that point.
I guess probably most people probably know, but pushing in that eyepiece, that's a huge source of error too. If you didn't push it in and you put it back in the case, you bent it, right? Which screws up the optical plummet. That's been happening a few times early on, but it's more so with, new people coming into the profession and not understanding that. But that can be
Yeah.
a big error. And as George threw in there, all more sources of error that we never pay attention to in our work. So there's so many sources of error, that's for sure. Good stuff. Questions, thoughts? You guys want to add some more to that? What you got, George? Is that a Pinot Noir?
That's his level bubble.
That's his level bubble.
Yeah, it's only half a bubble off. I'm going to go get the other half here in a little bit. It's a cab.
It's a cap. All right, there you go.
It's really interesting. You look at these compensators and they're fluid and they're liquid. And if you look at some history, of how they were using this stuff, they had all these fields in Mesopotamia, and their grading was perfect and their use of the water was perfect. And they had a like a bowl. Well, you got your water level with a tube. They had a bowl, and when it was level, they had it'd be a blue line, and then if they wanted 1% slope, they had a red line. You put the water on the red line, stick a straw through there, and you got yourself a level. Pretty simple.
Yeah.
In the Midwest, we ran a lot of levels. We can't do that in Nevada, but what we used for level was the horizon. It doesn't work here, but it did back there.
For sure.
It's when the world was flat, George.
Well, it still is to some people.
That's awesome. Oh, that was so good. I love it. Thanks, Marty. That was so good.
Thanks, Marty.
Yeah.
Good job.
Yeah, and I'll send you some stuff, and then I'm hoping to find some time to write a little procedure for just doing the calibration with the wedge.
Oh, yeah, that'd be awesome. In the chat, Ashley says, I'm currently a student entering the land surveying, field of land surveying. What's one thing you wish you had understood earlier about instrument, air, and precision standards? That's a great question. I would say from Marty's standpoint, I mean, you did the electrical engineering, so you probably
Yeah.
you got so many years back. I mean, you really got to understand it. I would say now.
Well, I guess I don't know. I've seen some magnetic anomalies. Um, an area north of Reno here with a lot of quartz that stuff just doesn't work
Yeah.
and hold elevations. But the biggest thing, um, surveyor will buy a new truck before he will buy a new instrument.
Yeah. True story.
What I wish I knew.
I just
Um,
think, like
boy,
that was the
that's a
importance of
tough one.
tonight. Yeah, I was gonna say the importance of tonight is just understanding, just like, we call the GPS magic box or the black box, right? Like it's understanding how it actually works and what you get out of it. I think that's the important part. I think I mean, you can really go down some rabbit holes of just understanding how the robot and the wavelengths and back and forth from mirrors, like you could really get into the weeds on some of that stuff. And I think that's probably some of the most important stuff of it, understanding those outside errors to kind of what you pointed out tonight. I mean, there's so many things that can go wrong just by bouncing into the back of the truck. And the robots inside a soft case equipment inside the truck, it's getting the least amount of bouncing around, but yet we put everything on that GPS rod or that total station rod that just bounces around in the back of the truck. And so I
Yeah.
think those
I
are,
think that I think the biggest thing to know and understand is ground to grid,
of
uh,
course.
how GPS works with like a robotic or with an actual
Yeah.
foot,
Yeah.
with what the contractor's doing. The contractor's just doing straight feet.
Yep.
And we're at, well, in my case, we're at 5,000 feet on a ball. So
Another one before we go to you, George. There's another one. What's your guys' preference on data collector models? I will say we have one TSC 5, and most of the people are not fond of it. That we have the TSC 7, so that's our favorite. But I would imagine that's probably market share at this point. Marty, TSC 7s.
yeah, I guess it really comes down to, what people like, whether they like the Windows or Android platform, really.
Yeah, exactly. Yep, that is for sure. Go for it, George.
Well, my advice to Ashley is always keep in mind that everything you do is subject to error.
Yeah.
Never assume that what you've got is correct.
Mhm.
Check it, double check it,
Mhm.
and if you have time and the ability, check it again. And the first thing you need to do is look at it and see if your answer looks realistic. You'd be amazed how many times you can get a bad answer from a piece of equipment. And if you don't realize that, hey, your measurement of 500 feet is really 550 feet, you're going to be in serious trouble.
Yep.
So just doubt your work and doubt your capabilities and keep checking yourself because you can't go wrong doing that.
That's great advice. Go for it, Jerry.
Yeah, and don't forget, no matter how accurately you measure the wrong thing, it's still wrong.
Yep.
One of the things that I find that I've seen the paradigm shifts that I've seen, and Martin did a real good example. When you hold up that transit, you can see every moving piece of that equipment and all the things
Yeah.
that can go wrong with it.
Yeah.
When you hold up a GPS receiver, you don't have that kind of physical connection with all those different error sources and that type of thing. But that's what's really important to understand is when you're working with a piece of equipment, a piece of technology, that technology still has some of those other errors that we dealt with before, setup errors and that type of thing, but it introduces a whole nother avenue of errors that we didn't have to worry about before. That just that longer discussion that I had in the chat there, I did some real quick
Yeah.
calculations for George's thing there, and I showed that even taping versus EDM, different kinds of errors, but the end result was the same expected error in 1,000-foot distance.
Yeah.
But you got to understand how those errors behave to know that what can you really do with your measurements.
So good. So good. Anybody else got anything before we let it's dinner time for us out west. So Marty wants to go eat dinner.
it's it's sleeping time.
Yeah, it's sleeping time in the Midwest. If nobody's got anything. That was awesome, Marty. I appreciate it.
That was very good. Very good. Excellent.
See you in a couple of weeks, Trent.
Yes, sir. And next week.
Well, yeah, in the next week I'll see you.
Yep, yep, yep.
I'll text you and let you know where we're staying and how we
Yep.
can get together.
Yes, sir. All right, everybody. Marty, as always. And
Very good.
anything
Excellent.
you get, shoot my way. Jacob just threw in there at the FIG conference, we discussed AI aiding the robot. There was an idea that the robotic total station may get to the point it can tell and predict where you are shooting, i.e., it may be trained to know TBC and codes are automated. What do you think of the AI going from here? Ooh, would you look at the time? No, kidding. What do you think, Marty? In 46 years, where's the AI headed? We didn't even get into
I mean,
self-leveling rods at this point, but
for collection, you're going to have um, object recognition. I mean, you can already recognize, cars and different things, but there'll be trees and the types of vegetation and, all your curbing and utilities and different things like that. As the databases get stronger and in more depth, you'll have that database of what's underground. And then on the layout side, we're going to see um, projections. I mean, we're already seeing some laser projection. So, you can set up in a room and just turn this thing on, and it's going to show you where all your walls and windows and bolts and light fixtures and everything goes.
yep, yep, yep. I will say one of the other ones I know, talking with Greg up there, they had a contractor that did full poured the curb with machine control and never even staked out a final curb stake on the
Yeah.
entire job. So
Well, and a lot of the
something
really
like
cool
that, I think, is
pictures
coming.
you see of fields and different things on hills are done with machine control.
Yeah.
They're steering the vehicles. They got a big motor that clamps up against the steering wheel and it drives the wheel. And we're seeing autonomy underground in the gold mines already. We've gone in with the LiDAR systems and mapped out the tunnels so the computer knows. And these vehicles are down there running on their own.
Crazy. Yep. I'm assuming that's probably how the third straw for Lake Mead. I mean, the big drill. I mean, that was probably all automated as well. But crazy. Good stuff. Great
Yes,
question.
sir.
Good question, Jacob. I missed you at the conference. I left on that Minneapolis on that Friday afternoon, so I missed you at the FIG conference. But we will we'll chat again. I love it. Thanks, everybody. Have a great week. Thanks again, Marty.
John, see ya.
Bye, guys.
Hey.